half-life. Is that up there? Yeah, good. Half-life's up there. That's great.
That's crazy.
Let's talk about half-life. Half-life is one of the trickier topics. We can do it though. We've got about 5 minutes left. I know it's been a pretty intense.
What about bored though? I never
session.
even learned bored.
Oh my God! Let's just throw a tantrum.
Read a book.
I don't know where it is.
You gotta be catching up then. We'll go over it right now. It's a review.
Right, yeah, but you said we were going to go over
But now we're wasting time talking about it, going over it. Okay. So, half-life is going to be the more trickier topic, one of the more trickier topics. You've got some substance. There's 100% of the substance. And then after one half-life passes, well, how much is left?
50.
50%. That's right. How did you know that?
It's half.
This is half-life. That's right. Okay. Now let's take another half-life. This is the second half-life. That's the first. That's the second. Okay. So now there's going to be 25%. And then if you do it again.
12.5.
Oh my God. This guy. He's like on it. Third half-life is going to be 25 or 12.5%. And then if we do it again.
6.25.
Oh, don't. That's too crazy.
Why did you have to do this?
6.25.
Oh,
Yeah. Okay, that's a fourth half-life.
no.
Right. Okay, that's a general idea. One half-life is a time it takes for half of the substance to go away, to decay. Right. Okay. So that's the most difficult part of this. The whole problem is figuring out what a half-life is, really. So once you understand that a half-life is just the time it takes for half of the substance to go away, then you're way ahead of the game. So I'm going to give you a question right now like this. I'm going to say, we've got how much of the substance? How many grams, Teddy? Tell me.
100.
100. Thanks, Teddy. 100 grams. Let's make it a little bit more difficult. Let's make it 3,100 grams. That's our initial amount.
Whoa.
That's how much we start with. Okay? Now I want to say, okay, so we've got that much initial mass of radioactive substance. Initial radioactive substance. Now, I'm not just going to stipulate. I'm going to say this substance has a half-life of how many days?
63.
Has a half-life of 63 days.
Yeah, fine.
Okay, how much time has passed? What do you think, Max? How much time has passed?
What?
Since we started with the substance.
Oh, how much time has passed?
Yeah, just tell me. Just make something up.
31 days.
Something higher than 63.
Oh, 82 days.
82 days. Okay, 82 days have passed. Sorry, 82 days have passed since we started looking at. Since we started with this amount, have passed. Okay, so that's the hard part of understanding this whole problem is knowing what the heck this means. So 82 days have passed since we started off with this initial stuff. Okay? So we have this stuff. We lock it in a box. Here it is. Here's a box that we lock it in. Lock it in the box. Okay? It's in there. And then we set our stopwatch for 82 days. 82 days have passed. Then we open the box back up and say, oh, how much is left?
Well,
and how do we figure this out?
so after one half-life, which is 63 days, you're going to have... Hold on.
Whoa, I thought we had an equation. This equation is given to you on your exam.
You take
It's the initial
initial
times 0.5, and then it's raised to the number of half-lives. That equals the remaining amount of substance. Remaining amount of substance. Right? Right. Okay. We gotta do this quick. So the initial, in this case, is that. Right? 0.5 stays the same. Number of half-lives. Now this is the tough part. We gotta figure out that from here. We know that one half-life is that many days. So one half-life equals 63 days. is the tough part. We know that. That's given to us. There are 82 days that have passed.
It's like 1.3 something.
So we say 82 days. We want to convert that into number of half-lives. So 82 days.
Divided by.
I'm just going to put this in this little equation right here.
Divided
So
by 63
1 over
days,
63.
which is
days.
1.3.
So that way the days cancel out. And is what? 1.63?
1.3.
Let's just leave it right there. That's how many half-lives there are. So that's the number of half-lives. So now you take this and you go over there, and that's the number of half-lives. So it's 0.5 raised to this power, 1.3. Then you take that quantity times the initial, and you'll get the remaining amount.
Very nice.
Which is?
1200. 1058.991.
1058
Got him. Get him. Bag it.
point something something.
Yeah.
Okay.
0.9.
Now it's going to be grams because we start off with
I got
grams.
527.
Okay, there it is.
3100 times 0.5.
That's it.
1.3.
Now, the Bohr model of the atom, yesterday we went over that. I'm only going to ask you very simple questions about that because there's not much we can ask you about that. Alex, this is the part where you got so nervous that you almost had a heart attack. So the Bohr model is something that is very, very simple. I'm not going to ask you too many questions about that. The questions I will ask you are about the concepts of the Bohr model. So yesterday we talked about this. We talked about how when an atom gets excited, its electrons get excited. So when you pump in energy into an atom, its electrons get all excited and they go up to a higher energy level, right? Then when they go up to a higher energy level, they don't stay there, they come back down eventually. When they come back down, they give off
like an
that energy.
rush.
But they give off that energy as light, right? And we have a little model of the atom that looks like this. Just real quick, I'm sorry I had to disrupt your staples there, Teddy. It's okay.
Great.
All right. It looks like this. The Bohr model of the atom looks like this. Oh my God. We got protons and neutrons all over the place. That's the nucleus, just like before. But now we got these crazy things called energy shells, or energy orbitals, or just orbitals, or whatever. They have electrons in them. And these electrons in them, they cannot exist in between these areas and here in between the shells. They can only exist at the shells. So this electron can go up here and go boop. Thanks. It can go up there and then back again. To go up, it needs to absorb energy. To come back, it releases energy. When it releases energy, it gives off light. That's the only thing that we learned yesterday, and that's the only thing I think you should know about this so far.
When it goes up and it comes back down, it releases light.
So when it goes up, it's absorbing energy. When it comes back down, it's releasing that energy as light. Okay.